Okay, so last thing on this. Supposing we're going to have a reaction between two things. All right, we have these two solutions that we already talked about. We talked about sodium phosphate and lead nitrate. So here they are. Now, so you go to start to react these two together. So what do you have? You have lead nitrate, PbNO3, that's a 3, 2, and sodium phosphate. We're going to react them. What could react with what? Sodium, lead's already been together with nitrate. Sodium's already been together with phosphate. What could react with what? Well, what's that? Lead could react with phosphate. They haven't been together, but also lead is positive and phosphate is negative. All right, what's their other option? Sodium could get together with nitrate. Is everybody okay with that? Okay, now, where does that fall in terms of solubility rules? What does nitrate precipitate with? No chose close, precipitates, falls out, is a solid with nothing. Right? So sodium and nitrate are not going to react to produce a precipitate. What about lead and phosphate? SCO-CRO-PO, what does PO precipitate with? What? Somebody said it. Everything. So what's going to happen if I pour those two together? Well, if I take this beaker here, and I pour in some sodium phosphate, okay, and what I'm going to do, what's that?
Goggles.
Goggles, yes, I know, I'm sorry, I'm sinning. All right, and I pour in a little tiny bit of lead nitrate. Can you see what's happening there?
That's cool. Just dump it all in.
Okay, you see that? All right, so what have we got there? We've got, what is that precipitate? What did you just tell me precipitated with what? PO4 is precipitating with the lead. All right, so you've got a solid in there. If I stir that up.
Wait, so is that PO4 lead? So PO4 PO.
So if I stir that up, it looks like it's kind of milky. But if I let that sit for a couple minutes, what do you think is going to happen? It's all going to precipitate back out again. All right, so it'll all sink back to the bottom. So what's going on here? So we've got, what did we have to begin with? We had lead ions, and we had nitrate ions, and we had sodium ions, and we had phosphate ions, right? And what fell out? What came out of the solution? PB, PO4, well, PB was what charge? 2. Phosphate was what charge? 3 minus. So what's the formula going to be? PB 3, PO4 2, and then what else are we going to have? We're going to have sodium ions and nitrate ions. Now, are they going to precipitate out?
No.
Okay. So now here's the thing. Have you ever heard of a word net? You ever heard you talk like about money, like net amount of money? You know what I'm saying? You've heard that? Okay, let me give you for instance. So my side business is I sell tie-dye t-shirts. Good money in tie-dye t-shirts these days. All right, so I'm selling tie-dye t-shirts. What's a good band to follow to sell tie-dye t-shirts? Give me any band. Not the Grateful Dead, they're kind of no longer existent. Pick one, anybody. A band! Sell tie-dyes. Come on, anybody.
One Direction.
One Direction, yeah. Okay, I can really see a bunch of little 12-year-olds in One Direction buying t-shirts. But let's just go with it. So I hear One Direction's playing Hershey in a couple of weeks. So I'm going to drive up to Hershey. I'm going to sell my tie-dyes. Now, being One Direction, I'm selling them for $30 a piece and getting it. All right, because these little good 12-year-olds just say, One Direction, and it's got a tie-dye on it even better. So I sell 40 freaking t-shirts at $30 a piece. 4-hour concert, $1,200. I'm liking this. All right, am I $1,200 to the good? No. Why not?
T-shirts cost money.
T-shirts cost money. The dye costs money. Gas getting up there is now a major factor, right? So I just spent money to make money. So let's say all of that cost me $400. So I'm still $800. Gross, I grossed $1,200. I net $800 because it costs money for all the stuff. So net is referring to the change from where I was to where I am now. I'm $800 to the good. If I could actually do this, I might quit my day job. All right? But, so what am I talking about here? Why did I bring that up? Because what we want to talk about is what's called a net reaction. Are there things in here that did not change? Well, the lead was alone, now it's together. That changed. The nitrate was alone swimming around, and now it is alone and swimming around. So it's not changed. So we're going to get rid of that for the net ionic reaction. What else didn't change? Sodium, right? So the net ionic reaction is lead plus phosphate goes to lead phosphate. That's what actually changed. What are the sodium and the nitrate? Well, there's a name for them. They're called spectator ions. And remember, what do we say? Why do we even have them there? Because their job is to, when you make the solution, is to bring the other stuff along. So when I wanted to make up that solution of lead nitrate, I needed to have nitrate so I could go get a powder and put the lead in there where I wanted it. If I wanted to make up a solution of sodium phosphate, I wanted the phosphate. I couldn't care less about the sodium. I go over into the stockroom, I'm going to find hundreds of sodium compounds because they're an easy way to bring the other stuff. Okay, so they just serve as a spectator. Does that make sense? So when we talk about net ionic equations, we're talking about what has actually changed.